So 37 says there's a foci at 0 and square root 13. So root 13 is obviously not on my graph. I know it's in between root 9 and root 16. So it's like at the 4 or 3.5 maybe mark. You can approximate it. And I don't really need it to be exact because what I'm trying to figure out from that foci is what is C and also where's my center and what kind of hyperbola it is. So if it's 0 root 13, that means I'm moving up and down. So right there, I know it's vertical. I know its center is at 0, 0. If it's vertical, my asymptotes are the A over B, okay? I know the center is at 0, 0, and I know C is square root 13 because you moved square root 13 in both directions. Then it gives me the asymptote is plus and minus 5x. So I know my center's at 0, 0. This 5 is my A over my B. Is that all you're given? Yeah. So you can make any combination of A and B that would equal 5. Does that make sense? I can make this over 1, and I can say A is 1 and B, no, A is 5 and B is 1. If it had part of the A and B, which is how we've been, like we've done both ways, but if you have part of the A or the B, then you have to solve specifically for the other one. But because I don't have either one, I only have C, I would test it out that way. So if I have 5 and 1, does that solve my root 13? Does C squared equal A squared plus B squared? Does root 13 squared equal 1 squared plus 5 squared? And what happens? It does not, right? Right? So I have to find a combination of that 5 and 1 in which it would solve that. So you can actually set up an equation, and I don't think this happened. No, I know it doesn't happen on the test, but I can say the square root of 13 squared equals A squared plus B squared, where one of those is the variable and the other one is 5 divided by that. So if I were to solve this for A, this would be 5B. A would equal 5B. So I end up with 13 equals A squared being 5B squared. Squared would be on the outside. Plus B squared. 13 would equal 25B squared plus B squared. 13 would equal 26B squared. B squared would equal 13 over 26, which is 1/2. Now I have the B. So this should have been B equals 1 over square root 2. That's your B. So then when you do A equals 5B, A would equal 5 times 1 over root 2. And I'd get A equals 5 over root 2, which if I was giving that as an answer, I would make sure I'd rationalize it. But I'm going to plug it back into the equation so I don't have to worry about it because I'm going to square it. So now it's vertical. Y squared minus X squared equals 1. Y squared would go over A squared. This squared is 25 over 2. X over B, which B was 1 over root 2. So that squared is 1 over 2. And then make sure you know how to get the bottom can't keep a fraction in it. So the 2 comes to the top. And I get 2y squared over 25 minus 2x squared equals 1. You don't need the over 1. You can put it there. It's not going to make it wrong. But that's what it should look like. So again, on the test, you're not going to go in blind on the A and the B. You'd have something there to solve. Okay, 39. Here, actually, I'm going to use the same graph. 39 says 4, 5, 4, 5, and 4, 1. These are your vertices, so I know it's vertical. I know the center is halfway between these, which would be 4, 3. And that A is 2. Then, so I already know vertical is y squared, so it would be y minus 3 squared minus x minus 4 squared. This gets the 2 squared, which is 4. I don't know the b squared yet, but it equals 1. Then it gives me the asymptotes. Y equals 3 plus and minus 7x minus 4. The 3 should match the k. The opposite of what follows the y, which is 4, should match the x, so that part's good. The 7, because it's vertical, equals my A over B. This is like more of what you could see because you already know the A. So the a is 2, so I would get 7 equals 2 over b. I would put it over 1, cross multiply. 7b equals 2, and b equals 2/7. So then when you plug it in, you're going to square it. 2/7 squared would be 4 over 49. That's the denominator. And then the denominator of the denominator has to go to the top. So y minus 3 squared over 4 minus 49 x minus 4 squared over 4 equals 1. So I would say that's more along the lines than the one we just did. All right, do the complete the square, and then if there's extra time, we'll go back to the extra examples of the hyperbolas. So for 4, you're basically going to complete the square first. Your job is to complete the square. By doing so, you're going to get one of your standard forms. From there, you would determine, is it a parabola, an ellipse, a hyperbola, and then from there, do whatever you got to do based on which one it is. If it's a parabola, you're doing vertex, focus, directrix, axis symmetry. If it's an ellipse, you're doing center, vertices, covertices, foci. And if it's a hyperbola, you're doing center, vertices, covertices, asymptotes, foci. So a review of complete the square. We've done it a bunch. Hopefully it's one of those skills that really sunk in, because you're going to see it again next year too. It doesn't go anywhere, okay? We start by keeping the ax squared and the bx term on the left side of the equal sign. So whatever's got the variables, we're going to put on one side, and then we're going to move the other terms to the right side. If there's something attached to this squared term, we have to take it out. Then we find the correct c term by taking the middle term, dividing it by 2, and squaring it. We add it to the left, and we're going to add it to the right. So that changed a little bit from when we did it with quadratic, because we kept it on the same side. So if you remember when we did quadratic, it would have said like y equals x squared plus 6x. And we wanted to keep everything on the other side. We kept y on the side by itself. So we would have said 6 divided by 2 is 3, 3 squared is 9. We would have added 9. And then if there was a number over here, so like let's say there was a -2, we subtracted 9, right? We kept it on the same side, and we balanced it by adding on one part and subtracting from the other. The difference now is we're okay with a number being on the other side. Sometimes we're going to have it that way. So we are going to add to both sides. Whatever you do to one side, you're going to do the same to the other side. So you're adding both times. And then from there, you're going to figure out, then you're going to factor it, and then you're going to figure out, do I have one variable squared where it's a parabola? Do I have both squared and they're both positive where it's an ellipse? Or do I have both squared and one's negative where it's a hyperbola? So from there, you're going to figure out which conic it is and then go from there. Yeah. You're going to take it out on the front. Yep. So we'll go through that. We're going to kind of baby step our way into that, okay? So for this one, first of all, these, like parabolas, you should be able to identify from the get-go, because there's only going to be one variable squared. There's only one variable squared here, right? It's a y squared. So not only do I know it's a parabola, but I also know it's a y squared parabola, so it means it goes right and left. I don't know which way yet, because there could be a negative I have to factor out. But for now, I know at least it's a parabola with a y squared. So I'm going to take the constant and move it to the other side with the non-squared term. So I get y squared minus 6y equals x minus 3. Now I've got to complete the square on the left side. So I'm going to take the 6. I'm going to ignore its sign because I'm always going to square it. So I'm going to take the 6, divide it by 2. I get 3, square it, and I get 9. I'm going to add 9 to the left, and I'm going to add 9 to the right. So again, we're doing the same thing because we're doing it to both sides of the equal sign instead of just keeping it on one side. On the left-hand side, I'm going to factor. Square root of y squared is y. Square root of 9 is 3. Sign from the middle is minus. Put it in parentheses and square it. Equals, I'm going to combine these two. Negative 3 plus 9, which is positive 6. Now that's a standard form parabola. If it's a parabola, you can't have anything on the front of the squared term. That's how I know it's standard form, okay? And there can't be anything in front of the x. If there was something in front of the x, I would have factored it out. So this is fine the way it is. I know this is a parabola. I know it's a y squared with a positive 4p. So it's going to face the right. I know my vertex is negative 6, 3. And my 4p is 1, so p is 1/4. Yep.
I'm testing going to ask for like the vertex and the 4p.
Yep. So it's going to tell you to put it in standard form and then answer, depending on what it is, answer specific questions. So for the parabolas, it would be what we just did, the vertex. And then also I've got to find, so negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3. It's going to point to the right. I've got to find the foci, or the focus, the directrix, and the axis of symmetry. So focus is 1/4 unit to the right, which means I'm going to add 1/4 onto my x coordinate of my vertex. So the focus is negative 5 3/4 and 3. So I just subtracted 1/4. No, I added 1/4, sorry, to negative 6 1/4. So negative 6. The directrix is 1 unit to the left, 1/4 unit to the left. And it's a line, it's a vertical line, so it's an x equals, and it would be negative 6 1/4. And then the axis of symmetry, remember, runs through the vertex. So it's a y equals the y coordinate of my vertex, which is 3. So if it's a parabola, it wants all that information. Vertex, focus, directrix, axis of symmetry.
I forgot, but why, when do we, you see the 9?
Yeah. Because you're not keeping them both on the same side. So when we did this with quadratics, we kept them like f of x equals, and we worked all on one side. Now we are going to work on both sides. So whatever you do to one side, you're going to do the same to the other. Yep.
In the beginning, you were like, we know this is a parabola, like, how do you know?
Because there's only one variable with a squared.
And if it's a parabola, it's like that.
Yep.
If it's like something, like, what about when it was like straight like that?
Like an absolute value? Won't happen. Yeah. You're either going to get a parabola, a hyperbola, or an ellipse. Like, you could also get a circle, but we won't do those. Yeah.
A hyperbola is what again?
A hyperbola is the one with the two parabolas that bounce.
Oh,
Yeah. Yep.
You have to graph in those type of questions in the test here.
No, but you're going to want to graph to get the information. Kind of like this. Like, I don't need this to be perfect. I just do that to help me get that stuff. All right, we're going to do it a bunch more times. Okay, this time I've got 2 squareds. I am not going to jump already and say that this is an ellipse because we're going to move things around, okay? But if they both start out positive, it's usually an ellipse. If they both start out negative, it could also be an ellipse because you might have to change the signs, okay? So wait until you're in standard form to figure out which one it is when they're both squared. So I'm going to group together. Now we get to not only complete the square once, we get to complete the square twice because there are 2 variables squared. I know, right? So fun. Just when you thought it couldn't get any better. So I'm going to group them. I'm going to group together the x's, x squared plus 6x. I'm going to group together the y's, 4y squared minus 8y, positive 4y squared. And I'm going to bump the constant to the other side. Equals negative 9. For the x, there's nothing on the front, so I can already go and complete this. I'm going to take the 6, divide it by 2. It's 3 squared, it's 9. Add the 9 here. Add the 9 on the other side of the equal sign. When I go to the y, this time there's something on the front of the y, so I have to take it out. So this becomes y, parentheses, y squared. It comes off of this and the 8, so that becomes negative 2. So I have x squared plus 6x plus 9 plus 4, take out the parentheses, y squared minus 2y minus 9 plus 9. So already these cancel out. I take the 2. I divide it by 2. It's 1. I square it. It's 1. I add the 1 here. Before I can add the 1 to the other side of the equal sign, I have to multiply by what's on the outside. And I end up adding 4. So if you take something out from the squared term, you have to multiply by what you're adding before you do that to the other side. So now I have 2 perfect square trinomials. I'm going to factor them both. Square root x squared, it's x. Square root 9, it's 9. Take the sign from the middle here, it's plus. Put it in the parentheses and square it. Plus 4, square root the y squared, it's y. Square root the 1, it's 1. Take the sign from the middle, it's minus. Put it in parentheses, square it. Equals 4. Negative 9 plus 4, which is 4. With me so far? Do you see already what kind of conic this is? What? Good. It's ellipse. There's 2 squares and there's a plus between them. What's wrong with this? It's not in standard form yet. Has to equal 1. I have to divide everything by 4. So I get x plus 3 squared over 4 plus, these cancel, y minus 1 squared over 1 equals 1. Again, you don't need the over 1. You can keep it there to remind you what that value is, but you don't need it.
So if there was a minus in between the values, then it would hyperbole?
Correct. So on these kinds of questions, there's going to be a part that says give the equation. There it is. That's the first part. Then based on what kind of conic it is, it's going to say find the center, find the vertices, find the co-vertices, find the foci. Can you see that? Oh, that's so hard to see.
That's what it's gonna be like on the test.
Yep. What do we know about this ellipse? Good. Center's negative 3, 1. It's horizontal because the a squared is under the x. A squared, remember, is the biggest with an ellipse.
And with hyperbolas, if it's the x squared, it's horizontal. If the y squared is vertical.
First, you mean?
Yeah.
Yes.
And then with hyperbolas and parabolas too, or just
Just hyperbolas. Yeah.
with ellipses, right?
With ellipses, the a, it's whichever has the bigger denominator
It's horizontal.
determines if it's horizontal or vertical, and that's your a. With hyperbolas, it's whatever's positive, so whatever's first, and then underneath that is your a. And then my b squared is 1, so b is 1. And then my c squared equals what for an ellipse?
A squared minus.
Good. Always the opposite of the sign of standard form. So because ellipse is plus, the c squared is a minus. If it's a hyperbola, the initial is minus, the c squared is plus. Okay, it's always the opposite. So I get c squared equals a squared, which is 4, minus b squared, which is 1. C squared would equal 3. C equals the square root of 3. You do not need to graph this, but in my opinion, it's way easier to figure out these vertices when you see it move. So my advice would be, like I said, I'm going to give you a graph paper. I would use it. Graph your center, which is negative 3, 1. We said it's horizontal because the bigger number is under the x. So I'm going to move right and left the a, and I already know the vertices. Negative 5, 1, and negative 1, 1. Up and down the b, which is 1, and now I know my co-vertices. Negative 3, 2, and negative 3, 0. and move right and left the foci, square root 3, which is a little bit bigger or a little bit smaller than root 4. So it's like a 1.8-ish. But I moved right and left, so the x coordinate gets the plus and minus root 3. So like I said, these feel like a lot of work, but the good thing is you're doing double work. You're doing complete the square, which is obviously something you need to do, but we also just completely reviewed ellipses, right? And graphing ellipses, which is part of what's going to be on your test. Yep.
For an ellipse, the a squared ever be under the second number?
It could be, it's just going to be bigger. It's whatever's bigger. So that order doesn't matter with an ellipse.
But then, like, if it's vertical, let's say, so the y squared is first.
That the order doesn't matter. It's what's underneath the bigger one, right? So if the bigger number's under the y, that's what makes it vertical. If the bigger number's under the x. Hyperbola, the order matters. Yeah. Sophie.
How many questions are on the test?
10.
But we're not the graph on the test, right?
Correct.
Is anything,
Not all of them, but yes.
is anything going to be above 10?
On your graph,
Yeah.
like to come off your graph,
Yeah.
maybe, but not by much. You might have to like just count the bottom. Yeah. But I get the full paper is graph paper, so there's no limit to your graph. Yeah.
How many of these are here?
Complete the square, there's 2. The same question? Okay. Yeah. Yeah. Like which part? There? Yeah. Yeah, because think about it. Like if I have x minus 3, even if it's plus something else, and I want to get rid of that minus 3, I'm going to add 3 to this side, I'm going to add 3 to this side. That's basically what you're doing. Yeah. All right, one more. Oh, sorry.
The outside stays throughout the entire.
I might add an example on like that. Remind me. Okay. All right, so this one says 4x squared minus 3y squared plus 8x plus 16 equals 0. So in this example, there are 2 squared terms, right? But there's only one that has the squared and the non-squared. There's only 2 of the x. Does that make sense? So I only have to complete the square with x. I don't have to complete the square with y because y is already a perfect squared. There's not a y squared and a y. When I regroup, if I get 4x squared plus 8x, and then that minus stays with the 3y, and I bump the 16 to the other side, so it makes it negative. There's not any other term here is what I mean. I don't have to complete the square on the y. Does that make sense? Okay, so I'm going to complete the square on the x. I'm going to take out a 4, and I'd get x squared plus 2x minus 3y squared equals negative 16. Take the 2, divide it by 2. It's 1, square it, it's 1. Add 1 here.
Why would you divide by 2?
Because you're taking that middle term. You always do middle term divided by 2 and square it.
But that is not 1 half. Oh, it's.
Yeah. So I added the 1 here. I would normally add the 1 here, but I took a 4 out, so I have to multiply it by 4 first. So I am adding 4. So now I get 4. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. Minus 3y squared equals negative 12. Now if I look from here, I know it's what kind of conic? Hyperbola. But if I judge from this step, if it's vertical or horizontal, which one has the negative? The y has the negative. What's wrong with doing it from here? It's not equal to 1 yet. If you look on the other side, not only is it 12, it's a negative 12. So when I divide everything by negative 12, what happens to my signs? They change. So now I have a negative in front of the x plus 1. This would be over 3 because this goes 3. And I have a positive, this would be 4, on the y. Now, once it's in standard form is when you're going to make this call. So I'm going to do one more thing and flip that order so that the negative comes second. Does that make sense? So that's why you can't tell until what it's equal to is 1, whether it's vertical or a horizontal hyperbola.
Which
hyperbola because one's positive, one's negative. But I'm going to switch this. So it's y squared over 4. So funny. It's so vibrant on my screen, and it is not on yours. Hang on, sorry. Y squared over 4 minus x plus 1 squared over 3 equals 1. So you want the first term to be positive. Yeah.
So if this were the case on the test and it had a negative part, it would be a hyperbola, we should switch it.
Correct. So now I know it's a hyperbola. I'm going to need my center. I'm going to need the vertices. It's actually not going to ask for the co-vertices, but I'm going to need them to make the box. I need the foci, and I need the asymptotes. Is it vertical or horizontal? Vertical, because the y is the positive one. Good. Center's negative 1, 0. A squared is 4. Good. So A is 2. B squared is 3. So B is square root 3. Remember, my vertical is A over B for my asymptotes. Foci, I need C. C squared equals, it's a hyperbola, so it's plus A squared plus B squared. C squared equals 4 plus 3. C squared equals 7. And C equals the square root of 7. I'm going to look at my graph because it will make it easier. My center, negative 1, 0. It's vertical, so I'm moving up and down the A. So I go up and down 2, and I already have the vertices. Negative 1, 2, and negative 1, negative 2. My co-vertices go right and left, root 3. So we're going to say that's just smaller than 2, like a 1.7 even, or 1.5 even. I won't be able to tell the difference between those. If it gave me the line for co-vertices, I would add and subtract that square root 3 from the x coordinate of my center. So it would be negative 1 plus and minus square root 3. But I don't think this question gives the co-vertices and the vertices. It's just 1. For the foci, I'm going to go up and down, because again, it's vertical, the square root 7. So it's negative 1 and plus and minus square root 7. I don't need to graph it, but it would be on there. And then again, if I were to graph this, I would make that little box. I would draw the asymptotes through the corners. Vertical would go off the top and the bottom. And my asymptotes are y equals k, which is 0, plus and minus a over b. A is 2, b is square root 3, x minus h minus a negative 1 becomes plus 1. So I'd end up with y equals, I don't need the 0, but I do have to rationalize that 2 over root 3. We won't go all the way through with it, but I just want to show you what happens with that negative. Okay, so this time I have 2 squared terms and 2 of them to the first, which means I'm going to have to complete the squared twice. First thing I'm going to do is group it. And when you group it, it doesn't matter what order you group it the first time, as long as you group your variables together. So I tend to keep the positive first, but it really doesn't matter because we're going to end up having to move this around anyways. So I group the y's, I group the x's, and I bump the constant to the other side. Now I have to take out the 4 on the front of the y squared. And it comes out of the 4 and also the 32. So this becomes y squared plus 8y. Now here's the tricky part, and a lot of people make this mistake. I have to take this negative off, but I'm taking it off of x squared and the 2x. Just like I did with the 4. So the minus comes off of both this and this, which changes this to positive, but this to negative. So be really careful when you're taking out that negative because it comes off of both. It'd be like just like taking out a number. Now I'm going to complete the square for both. So 8 divided by 2 is 4. 4 squared is 16. I add it here. I normally add it here, but I have to multiply by that 4 first. Oh, why'd I do it in my head? Sorry. Hang on. One step in front. Plus 16, multiply it times 4. And I'd get plus 64. Now I'm going to do the same thing with the x. Take that 2, divide it by 2. It's 1. 1 squared is 1. Add the 1 here. And again, normally I'd add it to the end, but I have to multiply by a negative 1 first, which means I'm actually going to subtract 1. So I have 4. Y plus 4 squared, square root, sign from middle, minus x minus 1 squared, square root, take the sign from the middle, equals negative 62 plus 64 is 2, minus 1 is 1. With me so far? Is this in standard form? It's in standard form. The only thing that's the problem is this 4 on the front would have to go to the bottom as 1/4. Okay? That won't happen on your test, but just know that that's what would happen. That's why I don't want to finish this one. I don't want to throw anybody off. But from here, once I did that, I would end up knowing that it is what kind of a? It's a hyperbola. What else do you know about it? It's vertical. Centered is 1, negative 4. Good. A would be 1/2. B would be 1. Do you know where we're going with this? Are we okay? Like, we don't need to do c squareds with fractions. We don't need to stress out about that kind of stuff. But do you understand that process? Yeah. Okay. All right. So for homework tonight, did I publish your review already? You're going to start your review and hang on. There is a web assign for this if you want the extra practice, but it's not assigned. So I would say if you want to do it, it is extra practice, but I'm not going to make it do. So it's completely up to you if you want it as extra practice. Where's the review? Oh, I didn't mean to put them. It starts with the parabolas, it goes to ellipses, it goes to hyperbolas, and then this last page is your complete the square. There's one of each kind. If you want the extra practice, I will publish the assignment on WebAssign, but I'll name it NG so that you know it's like not due, and I won't put anything on Canvas for that assignment. You don't need to do it. My advice would be to focus on as much of the review as you can tonight. I will also post a solution so you can check it. You do not have to turn it in. But the better would be to know tomorrow, like, where your holes are, where the gaps are, where you have questions. We will obviously do extra practice tomorrow. But this review covers all the stuff that's on the test.